Welcome to our channel. In today's session, we are going to discuss about polynomials. Children, you have already know about polynomials in class 9th. So today's session, we are going to discuss about polynomials. We will discuss about linear polynomials, quadratic polynomials and cubic polynomials, and we'll discuss geometrical representation of their zeros. So let's start with the definition of polynomial. Children, when we have a variable x and n be any natural number and we have few real numbers a0, a1, a2, a3 and so on, then the general form of polynomial p of x is written as an x power n plus a n minus 1 x power n minus 1 and so on till a0. You can see here the degree of polynomial, it keeps on reducing, it keeps on decreasing. Remember here one thing which we mentioned, that here n is a natural number, means the degree of polynomial must be a natural number. It can be 0, it can be any whole number, but remember degree cannot be negative number or it cannot be a fraction. Here this side I have written few examples of polynomial. Example number 1, it is minus 2x plus 7. This is an example of polynomial. As you can see here, the degree of x is 1. Similarly, the highest power in the second example, x square plus 3x is 2. Therefore, this is also an example of polynomial. 4x square minus x plus 6. This is here, you can again see here the degree, the highest power of the variable here is 2. So this is also an example of polynomial. But few examples of the expressions which are not polynomial, this one, 5x power minus 2 plus 1. Children, you can see here the degree of this variable is negative and we have already discussed that n should be a natural number. So this is not an example of polynomial. Similarly, here the degree of x is 1 by 2, again a fraction. So this is again not a polynomial. In the last example, we have 4 under root y plus 12. So when you rewrite this equation will become 4 y power 1 upon 2 plus 12. As we all know that when there is a root on any number and when we remove that root, the power become 1 by 2. So again here in this example, degree of the variable y is 1 by 2. So again this is not an example of polynomial. Now let us discuss about the quadratic, other classification of polynomials, right? So now we have classified this polynomial based on two things. Number 1, the based on degree. Number 2, based on number of terms. Let us discuss about how to classify polynomial based on degree. Children, if the degree of the polynomial is 1, I am repeating, if the degree of polynomial is 1, then it is said to be a linear polynomial. For example, here 2x plus 6. Here you can see the variable x, the power here is 1. So this is an example of linear polynomial. Similarly, if I write say 3x plus 8. So again you can see in this example the degree of x is 1. So again this is an example of linear polynomial. So linear polynomial is a polynomial where the power or the degree of polynomial is 1. Next is quadratic polynomial. When the degree of the polynomial is 2. When the degree of polynomial is 2, then it is said to be a quadratic polynomial. For example, 3x square minus 4x plus 7. Children, here you can see we have used variable twice, here and here, but the highest degree of the variable here is 2. So that is why this polynomial is said to be a quadratic polynomial. And the next one, if the degree of the polynomial is 3, if the degree of the polynomial is 3, then it is said to be a cubic polynomial. For example, here in the example, we have example minus 5x cube plus 4x square minus 3x plus 5. So you can clearly see here the degree or the highest power of the variable is 3. That is why this is said to be a cubic polynomial. Okay, so again we have linear, we have quadratic, we have cubic based on the degrees. If the degree is 1, it is linear. If the degree is 2, it is quadratic. And if the degree is 3, it is said to be a cubic one. Now, based on number of terms, how we can classify polynomials? So, number of terms, if the polynomial have only one term, then it is said to be a monomial. For example, 2x. You can see in this polynomial, we have only one term, that is 2x. Another examples of polynomials are, say, 5y. We can also write, say, 7t. So, this all are the examples of monomial. Here we have only one term in this polynomial. Second example or the second category is said to be binomial. Number of terms in a polynomial are 2. There are 2 terms in a polynomial, then it is said to be a binomial. For example, x square minus 4x, or we can write 2x plus 7. So you can see here in both the examples we have 2 terms, okay, and when the number of terms in a polynomial are 3, there are 3 terms, then the polynomials is said to be trinomial. So when we have one term, it is monomial. When we have 2 term, it is binomial, and when we have 3 term, it is said to be a trinomial. And this is an example of trinomial. In the next thing, we are going to discuss about zeros of a polynomial. So a real number k is said to be a zero of a polynomial p of x if when we substitute k in this polynomial, this becomes 0. I am repeating again, a real number k is said to be a zero or the root of a polynomial p of x if when we substitute k in the polynomial p of k becomes 0. Let us discuss this with the help of one example of a linear polynomial. So here we have an example of linear polynomial 2x plus 3. So children, we have already learned this in class 9th, how to find out 0 of a polynomial. When we substitute x here minus 3 by 2 in the place of x, when we substitute x is minus 3 by 2, you can see this 2 and this 2 get cancelled, and minus 3 plus 3 gives you 0. So on substituting x is equals to minus 3 by 2, you are getting 0. It means minus 3 by 2 is the 0 of the given polynomial. Now children, remember one thing, we have taken one example of linear polynomial, and in linear polynomial there is one and only one root or a 0 of a polynomial. We cannot find more than one 0 for a linear polynomial. Let us discuss 0 of a linear polynomial with the help of one example. So I am writing an example, say p of x is equals to 2x plus 4. So children, if I substitute here x is equals to minus 2, let's see what is going to happen. P of minus 2. It means in place of x, everywhere in this polynomial we will substitute minus 2. So that gives you 2 in a bracket minus 2 plus 4. Now 2 into minus 2 gives you minus 4 plus 4, and that becomes 0. It means when we substitute minus 2 in place of x, we are getting 0. So this x is equals to minus 2 is a 0, or we can say root of a linear polynomial. In this way we can find out zeros of a polynomial. So in the next thing we are going to discuss about zeros of a quadratic polynomial. Children, let us recall what is quadratic polynomial. Quadratic polynomial is a polynomial where the degree of the variable is 2. Now I am showing you an example here. Polynomial p of x is equals to x square minus 3x minus 4. This is an example of quadratic polynomial. As you can see here, the degree of the variable is 2. Now children, we know to find out a root or the 0 of a quadratic form polynomial, we need to factorize it. So we are factorizing this middle term 3x as we are substituting minus 1 here in place of x. So when you substitute minus 1 here, you can see p of minus 1 is going to give you 0. So when we put minus 1 in the given equation we are getting 0, it means minus 1 is one of the example of a root of this particular quadratic polynomial. Similarly, if in place of x, if we will substitute 4, so on substituting 4, let's see what happened. We are getting 4 square minus 3 into 4 minus 4. Now 4 square gives me 16. 3 into 4 gives you 12 and minus 4. So 16 minus 12 gives you 4, minus 4 gives you 0. So you can see here on substituting minus 1 we are getting 0 and on substituting 4 we are also getting 0. So here we can say that this minus 1 and zeros are the roots or the solution or the zeros of quadratic polynomial. Clearly you have seen that here we are getting two values, so it means this minus 1 and 4, both of them are the zeros of this quadratic polynomial, and we can also conclude from here that quadratic polynomial have at most two zeros. Now after zeros of a polynomial, we have discussed about the zeros of linear polynomial and quadratic polynomial. Let us understand geometrical meaning of the zeros of a polynomial. Here in this section again we will start with the discussion of linear polynomial, then quadratic, and after that we are going to discuss geometrical meaning of the zeros of cubic polynomial. So let's start our discussion with the zeros of linear polynomial. So general form of linear polynomial is ax plus b, where a is not equals to 0. Children, we know whenever we plot a graph for a linear equation or linear polynomial, it will always a straight line. Let us understand this with an example. Here I am taking an example. Let y is equals to 2x plus 3 is an example of linear polynomial. As you can see here, the degree of the variable is 1. So now when we put x is equals to minus 2, we are getting y is equals to minus 2. We are trying to find out few solution of this linear polynomial so that we can plot them on the graph to find out what is the solution of this linear given polynomial. Alright, so we are going to start with x is equals to minus 2. Remember here, I have substituted x is equals to minus 2, but you can put any value for x here to get the simultaneously value for y. So on substituting x is equals to minus 2, right, put minus 2 here, so we are getting 2 into minus 2 plus 3. Now 2 into minus 2 gives you minus 4 plus 3, that is equals to minus 1. So it means this minus 2 comma minus 1 is one of the solution of this y is equals to 2x plus 3. Now in the next step, put any value for x. I am substituting here x is equals to 2. So 2 into 2 plus 3 gives you 2 into 2 gives you 4, 4 plus 3 gives you 7. So again 2 comma 7 is the another example of a solution. Again I am telling you children, these are the two examples which I am using here, but you can use or you can substitute any value for x to find value for y. Now let us plot these two things on the graph. So when you are plotting these things, minus 2 comma minus 1 on the graph here, this is minus 2, this is minus 1. So this point represents minus 2 comma minus 1. Now 2 comma 7, this point 2 is here on x-axis and 7 is here on y-axis. So when you are plotting, this 2 comma 7 is this point. Now when you join this two point, you will see that and you will notice that this straight line intersect x-axis at a point. You all can see it intersect x-axis at a point, and the coordinate of this point is minus 3 comma 0. So where now you can see this graph of linear equation intersecting x-axis at one point, only and only at one point, and then that one point is known as solution of the given linear polynomial. So children, clearly you can see the coordinate of this point where it intersects x-axis. The coordinates are minus 3 by 2, minus 3 upon 2 comma 0, because it is on x-axis, so y coordinate is 0. So this minus 3 upon 2 comma 0 is the solution of the given linear polynomial y is equals to 2x plus 3. I'm repeating this thing again. When we have a linear polynomial, we know when we plot the graph of linear polynomial, it will intersect x-axis at only one point, and then that intersection point coordinates are known as solution or the zero of the given polynomial. After linear polynomial, let us understand geometrical representation of zeros of quadratic polynomial. So children, we know quadratic polynomial is a polynomial with the degree of the variable is 2. Okay, so here we know that the graph of quadratic polynomial, when we will plot a graph, it will be of the form parabola. It will be a like upward U or a downward U, right? So here we have a general equation ax square plus bx plus c, where a is not equals to 0 is a quadratic polynomial. When we plot this graph, here we will get upward u like this, or we will get a downward u like this. Children, such curves are known as parabola. Okay, now here we are again taking one example of quadratic polynomial. Example is x square minus 3x minus 4, and we are equating this expression to y to find out certain solution of this particular expression. So now initially I am substituting x is equals to minus 2. So when you substitute minus 2 here in place of x everywhere, you will see that y is equals to 6. When we substitute x equals to minus 1, we will get 0. Let us take one example. So we have y is equals to, I am substituting x is equals to minus 1 here. So minus 1 square minus 3 into minus 1 minus 4. So children, minus 1 square going to give you 1. Minus 3 minus 1 plus gives you plus 3 and minus 4. So we have 4 minus 4, that is equals to 0. So in this way you can find out n number of solution for this particular equation. Here we have put minus 2, minus 1, 0, 1, 2, 3, 4, so on, and simultaneously we got values for y, that is 6, 0, minus 4, minus 6, minus 6, minus 4, 0 and 6. Now when we plot all this point, this is x coordinate and this one is y coordinate. When we are plotting this points like minus 2, 6, we will plot minus 1, 0. On this graph, children, you can see we are getting a upward U. The shape is said to be a parabola, upward U. And this graph, children, you can see, you can notice one thing, that this graph or upward parabola intersect x-axis at this point and on this point. So the graph of a quadratic equation intersect x-axis at two distinct points. Here the first point or the coordinate of the first point is minus 1, 0, and the coordinate of the second point is 4, 0. So these 2 points where the graph of quadratic equation intersect, these 2 points are actually the solution of the given quadratic equation. Here we have different cases. We will see all the cases one by one. You can see here either it is intersecting at 2 points, or you might come across a situation where the parabola intersect x-axis at only one point, or it will not intersect x-axis at all. So we are going to see all the 3 cases one by one. Now here you can see these are the special cases, children. You know that p of x is equals to ax square plus bx plus c. This is the general form of quadratic equation. Now whether we are going to get upward u or upward parabola or a downward parabola, this actually depends on the coefficient of x square. Here you can see the coefficient of x square is a. So children, this is a very important point which you need to remember. If a, that is the coefficient of x square, if this coefficient is greater than 0, then in that situation we are going to get upward parabola. But in case if the coefficient of x square is less than 0, right, you can see this graph is for the second case. Here the if the coefficient of x square is less than 0 means it is a negative number. So when it is a negative number, in that case we are going to get a downward parabola. So children, this is very important point. Number 1, when a is greater than 0, we are going to get upward parabola or upward U-shaped graph, and when a is less than 0, in that case we are going to get a downward parabola or downward U. Children, there are few special cases as well. Here you can see these are again example of parabola, but you can see here this parabola or this downward parabola intersect x-axis at only one point, and similarly here also in this upward parabola, this parabola intersect x-axis at only one point. So these are the special cases. It means this point is the only solution of this quadratic polynomial. Here both the points of the parabola are intersect and they coincide to form only one point. So this A is the only solution in this case. We have one more example where you can see this is again a graph of a quadratic equation only, but you can see this graph, there is no intersection point between the graph and the axis. So you can see since there is no intersection point, it means in such situation there is no solution for quadratic equation. So what we can conclude, we have seen earlier we have two solutions, in the next we have one, and here we have zero solution. It means quadratic equation or quadratic polynomial at most have two solutions. It can also have one solution or no solution as well. Now next thing is about cubic polynomial. Now we are going to discuss about the geometrical representation of the zeros of cubic polynomial. Let us discuss what is cubic polynomial is. You know, cubic polynomial is a polynomial where the degree of the variable is 3. So here the general form of the cubic polynomial is ax cube plus bx square plus cx plus d, where a is not equals to 0. This is a general form of cubic equation, and this example we have taken for cubic equation x cube minus 4x. So when y is equals to x cube minus 4x, and in the same way only we will put some value for x and simultaneously we will get the value for y. So this solution, this is a solution table for this particular cubic equation. Initially we substituted x is equals to minus 2, we get y equals to 0, minus 1, we get 3. So this minus 2 comma 0, minus 1 comma 3, 0 comma 0, so on. This all are the solutions of this particular expression y is equals to x cube minus 4x. Now when you plot these solutions on the graph, you can see you are getting a curve like this, a wave curve here, and you can see this curve of this cubic equation intersect x-axis at 3 distinct points. This is first point on x-axis, this is the second point, and this one is the third point. So now clearly, since the graph of cubic polynomial intersect x-axis at 3 distinct points, it means this coordinates of the 3 points minus 2 comma 0, 0 comma 0 and 2 comma 0. These 3 points are actually known as zeros of cubic polynomial. So now let us conclude the things which we have discussed. Suppose if we have a polynomial of degree n, it can be any number, it can be 1, it can be 2, it can be 3, it can be 4 and so on. So when we have general a polynomial of degree n, then the graph of that polynomial intersect x-axis at n distinct point, and it means that particular polynomial have n number of zeros. And when we have a linear polynomial, we have already discussed linear polynomial graph intersect x-axis at only one point. Quadratic polynomial, the graph of quadratic polynomial intersect x-axis at 2 distinct points. So it means it have at most 2 solutions, and the graph for the cubic equation have 3 distinct points. It means it intersect cubic polynomial at 3 distinct points. So it have at most 3 solutions. Thank you children. Thank you viewers for watching this session. In the next session, we are going to continue with the relationship between the zeros of the polynomial and the coefficients of the polynomial. Thank you again.